Alright, today we're going to be looking at adding and subtracting with radicals. And when we're adding and subtracting radicals, it's kind of like working with variable expressions. So quick little review over here to the side. If I were to add 2x plus 3x, well, they have the same variable, so I can add those together, and those would give me 5x, and that would be the simplified form. Working with radicals is basically the same type of thing. We have to make sure that the radicals are exactly the same. They have the same number inside of them. So looking at our first example here, this one says the square root of 7, and this one says the square root of 7. So therefore, we can treat those the same. So I add 4 plus my 5, which gives me 9, and my square root of 7 is just along for the ride. Looking at number 2 here, this one's a subtraction problem. 8 times the square root of 11 minus 2 times the square root of 11. Here, my radicals are the same. Since my radicals are the same, I can take and just subtract 8 minus 2. 8 minus 2 gives me 6. And then I have the square root of 11 still in the radical. Looking down here at number 3, here I have a square root of 6. Here I have a square root of 6. So these two are the same. So I can combine these two here together. So I have 3 of them and 5 of them. And 3 plus 5 gives me 8. Square root of 6. This one is not the same because he is not the same radical. So he's just going to be tagging along at the end. So a minus 2 square root of 13. Looking at our next one here, let's go through and collect. Here I have square root of 3 and square root of 3. These are the same, so I can combine these two together. So I have 7 take away 1, which would give me 6 times the square root of 3. Here I have a square root of 2, and here a square root of 2. These two are the same, so I can combine those. So I have 2 take away 3. Oh, that's going to be a minus 1 square root of 2, but we don't put a 1 in front of it, just like with the variable. It's understood to be there. Now looking here at number 5, and number 5, they don't look the same, but wait a minute. This is an awfully big number, so we got to see if we can simplify it first. And what I would always start with is by whatever number this one is. So let's take 192, and let's divide it by 3 and see what we get. Dividing this by 3, that's going to go in here, leaving 6. That's going to be a 1 and a 2, so 3 goes into 12, 4 times 64. So this one is really going to be 5 times the square root of 64 times 3 minus my 7 square root of 3. Now, since 64 is a perfect square, he can come out now. So I now have 5 times, well, the square root of 64 is 8, and that part is done. And I have my square root of 3 left. This minus 7 square root of 3 is just along for the ride, chilling at the end. I got to multiply 5 times 8 now, so 5 times 8 gives me 40 times the square root of 3 minus my 7 square root of 3. Hey, look, now these are both square root of 3. Since they're both square root of 3, I can say 40 minus 7. 40 minus 7 is 33. And I got my square root of 3 chilling at the end. Looking here at number 6, none of these things seem to be matching here. I've got a 2, I've got a 27, and I got a 98. Well, I know that 2 doesn't go into 27, but I think I can probably simplify that one. 2 does go into 98, so let's see. This first one, he's not going to change. He's staying along because 2 is a prime number, small as I can make it. Plus, this one here is going to be 2 times the square root of 9 times 3, because 27 is 9 times 3. minus, this one's going to be the square root of 49 times 2. Well, the first one stays the same, 25 square root of 2 plus 2. 9's a perfect square. So that can come out and become a 3. He's gone. And I'm left with square root of 3 in the radical. Minus, here I've got 3 times 49's a perfect square. Since 49's a perfect square, it comes out as a 7. Because the square root of 49 is 7. And I'm left with the square root of 2 here. So go do our multiplication on the outside of our radicals. So my 25 square root of 2 is still just chilling here. This becomes 6 square root of 3 minus 21 square root of 2. Hey, look. This one and this one are the same. So I have 25 take away 21, which gives me 4 square root of 2. And then I have a plus that piece right there. So plus 6 times the square root of 3. Looking here at problem number 7 here, I have a square root of 3, a square root of 6, a square root of 48. I can probably break that one down. Oh, and here is a square root of 54. 3 and 6, they're cooked. Can't do anything to them, so I have 7 square root of 3 minus 4 square root of 6 plus 48 is the same thing as saying 16 times 3. I use 16 because 16 is a perfect square. Minus 6 times the square root of 54 is 9 times 6. I use 9 times 6 because 9 is a perfect square. So looking here, my 7 square root of 3 is still just chilling out front. My 4 square root of 6 is chilling right next to him. This next one becomes 2 times, well, 16 is a perfect square. Since 16 is a perfect square, it comes out as a 4. And I'm left with the square root of 3 in my radical. Minus 6 times, well, 9 is a perfect square. So therefore, the square root of 9 is 3, so that one comes out. And I'm left with the square root of 6 in my radical. My 7 square root of 3 is hanging here. 4 square root of 6 hanging out here. This becomes 8 square root of 3 minus 18 square root of 6. 7 square root of 3 can be combined with 8 square root of 3, so 7 plus 8 is 15 times the square root of 3. Next I have a negative 4 square root of 6 and a negative 18 square root of 6. So negative 4 and negative 18 give me a negative 22 square root of 6. You need to always make sure that each radical has been simplified as much as possible, and then combine any like radicals together, just like we combine like terms with our variables. As always, pay attention to what you're doing, and good luck.